Alright, let's look at the homework 10.4, problem number 4. Alright, so let's apply Taylor's theorem to find the power series. Alright, so let's do that. Alright, so we're going to take a bunch of derivatives. So we have f prime of x is going to be equal to, alright, 5 is just a constant multiple, and derivative of e to the negative x is negative e to the negative x, right? And the second derivative is going to be, right, negative 5 is just a constant. Derivative of e to the negative x is negative e to the x. So this is going to be positive, right? And then third derivative is going to be, you can see that it's a negative 5 e to the negative x, right? And so on, right? So you can see that if you take the nth derivative, right? So what should we get, right? So the sign is alternating, so it's going to be negative 1 to the nth power. Looks like if you take the even number of derivative, it's going to be positive. Odd number is negative, so this will do it. And everyone has a 5 e to the negative x, right? So if you want to find the power series, right? So it's a summation, and it goes from 0 to infinity, right? So we need to find the f nth derivative f and plug in the center, in this case 1. So it's going to be negative 1 to the n. Alright, so you have 5 to the e to the negative 1. So we can write it as 5 over e. Right? So that's that. So you have, right? So it's a negative 1 to the n times 5 over n factorial, right? And then x to the, x minus 1 to the n, right? So let's type it in. Right, so we have a fractional form. So you have negative 1 raised to the n times 5 over n factorial. Oh, and I forgot to put e, sorry, e times. Right, then we have x minus 1 to the n. Alright, let's see, did I forget to put the, yeah, I forgot to put e there. Alright, so we have that. Alright, so let's check the answer. Alright, I came back and looks like we got the power series correctly. Alright, so let's find its radius of convergence. Alright, so to find a radius of convergence, we need to apply a ratio test. So limit as n approaches infinity, then you have absolute value of, alright, so an plus 1. So we just have to rewrite this guy, and we just have to put n plus 1 instead of n. So 5 is 5, and then you have x minus 1 to the n plus 1 over e, then you have n plus 1 factorial, right? And divide by an is just multiply by its reciprocal, so you put e and n factorial on top, and you have a negative 1 to the n times 5 times x minus 1 to the n. Alright, so we're going to be able to cancel let's see, we can cancel, there's a 5 on top and a 5 on the bottom. E on top, E on the bottom, cancel out. So, and you have n factorial, and cancel that. Then you have n plus 1 left over on the bottom. And of course, negative 1 to the any power does not affect anything. And x minus 1 to the n, cancel that. You have x minus 1 left over on top. Right, so x minus 1 has nothing to do with n, so it's a constant. So you're going to have, let's see, x minus 1 with the absolute value sign can be kicked out. Right, then what's left is limit as n approaches infinity. Right, nothing really left is on top. And then you have n plus 1 on the bottom. All right, but you can see that here this limit is going to go to 0. So this is going to be 0, which is less than 1 for any x value. So the radius of convergence is infinity. All right, so let's type it in, and infinity. All right, let's check the answer. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.